The long solution of differentiating an equation to find the slope follows a four-step algorithm. Learn how it goes here in differential calculus. With the equation y is equal to 2x cubed minus 3x, find the slope at point -1, 1. The first step is to replace the variables with their counterparts, adding deltas. So the equation turns out as y plus delta y is equal to twice the cube of x plus delta x minus 3 times the quantity of x plus delta x. Now let's expand the first term and distribute -3 from the second term to get y plus delta y is equal to twice the quantity of x cubed plus 3x squared delta x plus 3x times the square of delta x plus delta x cubed minus 3x minus 3 times delta x. And another distribution of the scalar can take out the parentheses, making the equation y plus delta y is equal to 2x cubed plus 6x squared delta x plus 6x delta x squared plus twice the cube of delta x minus 3x minus 3 times delta x. Secondly, isolate delta y by transposing y to the other end. And since y is also 2x cubed minus 3x, we can distribute the negative sign and cancel out 2x cubed and 3x, giving a shorter equation, delta y is equal to 6x squared delta x plus 6x multiplied by the square of delta x plus 2 times delta x cubed minus 3 delta x. The third step is to divide the whole equation by delta x to come up with delta y with respect to delta x, and the operation cancels a part of each term, resulting to delta y all over delta x is equal to 6x squared plus 6x delta x plus 3 times the square of delta x minus 3. Then the last step is to take the equation's limit as delta x approaches 0. And by doing so, we zero out 6x delta x and 3 times delta x squared. So dy over dx turns out as 6x squared minus 3. Now for the slope of a specific point of the curve, y prime turns out as 6 times the square of -1 less 3, making y prime as 3. The next example is to look for the slope of the equation y is equal to 9 minus 2 all over x raised to the fourth power at point 1, 0. With the same algorithm, we can incorporate the deltas, providing y plus delta y is equal to 9 minus 2 all upon the fourth power of x plus delta x, where we can expand the denominator to free the binomial from its parentheses. And since the exponent is 4, it is easy to identify the coefficients using the Pascal's triangle, which are 1, 4, 6, 4, and 1. After the expansion, we have the equation y plus delta y is equal to 9 minus 2 all upon x to the fourth power plus 4x cubed delta x plus 6x squared times the square of delta x plus 4x delta x cubed plus the fourth power of delta x. This is the simplest we can get from step 1. Moving to step 2, we transpose y to keep delta y alone. Then we can cancel 9's after. Leaving our equation, delta y is equal to negative 2 all upon x is to the 4th power plus 4x cubed delta x plus 6x squared times delta x squared plus 4x times cube of delta x plus delta x to the 4th power plus 2 all over x to the 4th power. Next is to take the LCD of the two fractions, and that is by taking both denominators by multiplication, and work out the updated numerators by equivalent fractions. Take out the parentheses by multiplying 2 from the numerator and x raised to 4 from the denominator. By doing so, two other terms are cancelled out, leaving us with the equation 8x cubed delta x plus 12x squared delta x squared plus 8x delta x cubed plus 2 times delta x to the 4th power. And everything is over x to the 8th power plus 4 times x to the 7th power delta x plus 6 times x to the 6th power multiplied by the square of delta x plus 4 times x raised to 5 with the cube of delta x plus x to the 4th power times the 4th power of delta x. Step 3 can simplify the equation as we divide delta x, or that is by multiplying the equation with the reciprocal of delta x to come up with delta y all over delta x is equal to 8x cubed plus 12x squared delta x plus 8x times the square of delta x plus twice the cube of delta x, and again everything is over x raised to 8 plus 4 times x raised to 7 delta x plus 6 times x raised to 6 with the square of delta x plus 4 times x raised to 5 with the cube of delta x plus x to the 4th power times delta x raised to 4. Lastly, take the limit of the equation with delta x approaching 0, by which delta x's from the equation gets zeroed out. So the long equation from the earlier is reduced to a fraction with just one term. With delta y all over delta x reduced to 8x cubed all upon x raised to the power of 8, the x's can be further worked out by the laws of exponents, where the final equation becomes y prime equal to 8 all over x raised to 5. Finally, with a point at 1, 0, where we plug in 1 into the equation, y prime becomes 8 all over 1 raised to 5, and that is simply 8.